Hey guys, came back again. New Year's Day. I hope you all had a great New Year's Eve. Ours was pretty quiet, but sort of get a bit beyond that, I guess. Everyone's crashed inside. Yeah, we've been down the beach all day today, so everyone's pretty tired. So I thought I'd take advantage of that and slip outside and make a start on the work on this slide plate. And we'll have a look at the drawings first, go through what we're going to do. This is the one I've had to make some small modifications to because of that little blue we made on the slides where that tool popped out of the holder and gave us a false cut or false machine is what I've heard the term used before when machine shops stuff up. You get a phone call, we've had a false machine. Yeah, well. What I'll do is I'll bring you up close, we'll go through the drawing, what we're doing, little changes we've made to overcome that little slip up we made. And we'll go about how we're going to go about setting this up and getting everything true and square. Alright, we'll be back in a tick and we'll set up and we'll look at this drawing. Well, just before we go and have a look at that slide plate, what we're going to do is just refresh our memories on that little slip up that we made, and that was on this slide face here where when we're running it through, the tool's dropped out and it's cut down another 0.5 millimetre deeper than what I had on spec. So because everything's very tight in here, particularly with the crank pin, I've thickened the plate up by another 0.5 millimetre to accommodate for this. That plate is going to be sitting down 0.5 millimetre closer to that crank pin, so that'll give us a little bit more meat that we can machine out the back of that slide plate, just to give us that clearance that we need. So I've already mentioned it, bearing in mind the fact that we have dropped 0.5 millimetre on these slides, so we're 0.5 millimetre closer to this face than what we should be. So we'll go and have a look at the drawing and we'll go through what we're going to be doing. Alright guys, hope you can see this alright. So this is the slot that we're going to be cutting into the back end or back face of our slide plate. As I said, I've made this as a modified drawing because we've thickened this up by 16.5, hence all of the dimensions have moved 0.5 mm inboard. I've kept these the same, which means that not going to affect us any. It's just how we make up the shear pin. We just have to make the shear pin 0.5 mm longer, which isn't going to affect us in any way. So on the back end there, we've got the register that we need to cut for the nut. We've got a little bit of a relief that we also need to cut in there for the back of the nut. You can sort of see that up in there in that ISO. And then we've got a run out that we need to machine in for the screw, so that it doesn't bottom out. So fairly straightforward, but a little bit of setting up to do initially, because this is going to be sitting on the underside in this orientation. These edges, I don't really want to use those as datum edges to work on. I want to use these machined edges here. So the drawing states at 125, but I've actually just checked it out with my micrometer. A bit closer, let's see. And that's measuring up dead parallel. You can get it. There we go there. That's 125.1. It's the same up that end there as well. Yeah, so that's dead parallel. So I want to use that edge there because it's actually sitting underneath the taper. Oops. I'm going to set it up like this. I've just got one of my 1/8 parallels that we're going to use to butt that up against to give us a datum point, and then we can work from there to get the center. So what I'll do is I'll set my my edge finder down. We'll pick up the edge of that, and we'll come across 125.1 divided by 2 to give us our center, and that'll give us our starting point. And then we'll reference off the edge to go for the depths. So we'll set up to get that organised, get that clocked up, and get us a point to start with, and we'll start doing the machining out for this cavity to fit the nut. Alright guys, back soon. Righto, so we've used the edge finder, we've picked up the edge of that parallel as we talked about, we've pushed the plate hard up against the side of that parallel, and we've come across our to our center point. I've touched off, got a depth, and now we're going to start roughing out the slot. So we use the 12mm cutter to rough out most of the slot work in this. So we'll make a start. Right, just before I back it out of here, you can see that step. I've taken roughly two 5mm steps down, but you can see how it cuts a step in there. And that's why I don't like to use these as they are for cutting a keyway. I like to be able to put a smaller cutter in and then slightly side cut to get them exactly right and just set them up with gauge blocks. But yeah, it always tends to pull one way. It'll probably take it out as I come back, but it will be oversized. So I'll just whip this out. I'll try and get in and measure that. We'll measure it this way, just out of curiosity. Yeah, so that has cut oversized to about 12.2. So as I said, I like to, if I'm doing keyways, run the cutter down because it will always tend to pull out to one side. It's always good to be able to have a smaller cutter that you can actually then side cut down the guts and then just take out each bit, climb milling as you go. Right, so that's the slot roughed out. I will take a little skim down the outside. This isn't a critical width on this. I'm going to use a 6mm cuttage to come down and soften that radius out a little bit as well. Alright, we'll set up for the next step, which is a 14mm slot. And the next slot is just to house that little extension on that block. So not critical, as I said. The critical dimension is on the outside there, which is going to locate. Alright, so that's it roughed out. I'll swap over. I'm going to put a 6mm cutter in here, and we'll do the final sizing and cleaning up with that. Alright, back in the tip. Alright guys, we put a 6mm cutter in here. We'll bring it back to depth, and we'll start side cutting out until we get to width. So I'll side cut out first, leaving 1/2 mm all round. I'm at depth at the moment, so we'll get the sides out. We'll clean them up and take these larger radiuses out as well. Now just looking at the depth or the width we need to make this, so this is 0.025 oversized, so that'll be my fitment. So we've got about 1 mil left to go on that. And what I'll do is I'll quickly measure that and see where we're actually at. Alright, so it's 35.02, so it's cutting pretty well to size. Alright, let's carry on. Let's see where we're at. This is the sort of stuff you don't want to rush. Just want to take your time. Now, about 0.2 to go, yes. 0.18 to go. Well, I ran that up and down a couple of times just to make sure we took any spring out. Okay, that's measuring up at size for size there. It's just starting to go in. All right, I'll hand fit that back. So, righto, we'll just drop that. Remember we talked about we're going to drop that slot down a little bit further so we don't need to take the 45s off of these corners. So we'll just clean up this bottom one next. Right, I'm just going to go straight to sizing this because we know that that cutter is cutting pretty well smack on diameter. Righto, that's that one done. We'll do the slot. We'll just open the slot up a little bit. What I might do is just plunge the end mill down to do the corners, so it's not going to vibrate out like crazy. So we'll set up the coordinates and we'll get that into position, and then we'll just come down to a very light lick on the side. This isn't a critical dimension; it's only clearance for the screw. Same as that one we just did. It's only clearance for the for that little protrusion off the nut. Right. Unfortunately, my camera stands right in the way of this, so I'm just going to do incremental turns and get into position. Oh, that's how it's come up. It's come up really nice. So I'm just going to do a little bit of hand fitting to get that nut in, as I said, and then we'll take the plate out. Flip it over and we can do the drilling and tapping using our datums to pick up a centre line on an edge, and then we'll drill through and counterbore for the cap screws to hold that nut in place. Right, let's go handheld for a minute. So that nut's now fitting in place. That was literally just a couple of strokes with a file to get that final fitment. Let's come up. Really well. So I'll just put the little 45s on there. Look, you could have put toolmaker's corners in there and just run those cutters down a little bit further. That way I wouldn't have had to worry about putting the 45s on, but at 6 of one, half a dozen the other, what you do. So that's it in place. Very happy with that. That's you can't even feel that transition. It's really very type of treat. Alright, so we'll flip this over now. I've got a drill and counter bore for the screws to hold that nut into place. And then we've got a fair bit of work to do here with these slots. So this is for the housing for the ram This is going to locate all that, so a bit of machining in that. So we'll get set up for that next, and we'll get that on the go. And we'll keep moving on. Righto guys, we've flipped the plate over. This is our top face here. I'm just clocking up in the dovetails. I need to make sure that that's dead parallel, so that when we cut in for this guide box for the ram that's going to sit in here, these need to be exactly at 90 degrees to that slide. So when we do the drilling and tapping for the counterbores, we're going to register or use the edge finder up against that edge, which was the same edge that we had upside down on the other side, and the top face. Then we can then drill through, counterbore, and get those holes located properly. Then we'll come down and start cutting those slots out. But we've got that zeroed up. Just hit the clamp, but that's 0, 0 all the way across there now. It was within about 0.02 of the back here, so just coming up against that knife edge. I just had to tap it away a little bit off the tenon at the back. So all right, we'll use the edge finder. We'll set up, get our center distances and our edge references. So for the drilling and counterboring, I'll be coming off the top edge up here, and then for the slides we'll come off the bottom edge here. Not critical in these in this Y direction, but relative to each other, we want to get them as accurately as we can. We've got a fairly tight tolerances I've put on that. All right, so we'll get set up, get centered up, and we'll get started. So we're down 6/14 offset. So I'm going to go in with a flat bottom drill. I'll go in with a pointed drill first. I want to make these almost a sized fit, almost like a dowel fit like we've done in the past with some of these socketed cap screws. It's got to be 5mm deep. So zero that out. Right, we'll get it set up now to do the milling of the slots for the keeper plates for this guide box for the RAM.